What we're going to look at next is it a function? So specifically, a function is a special type of relationship in which each element of the domain is paired with exactly one element of the range. So you remember that one that we did where we were looking at the mapping and I said, well, the number is going to two things. Well, look at over here. This says that our input, -9, is going to 5 and -2. Does that meet our criteria of going to exactly one element of the range? Nope. So this would not be a function. And I abbreviate function fx. So on number 13, each element of the domain, I don't see any repeats in it, has exactly one number that it's outputting to. So this one's a yes. And then over here at number 15, -7 goes to 2, -5 goes to 2, -2 goes to 8, and 0 goes to 8. It's okay if the range repeats, but if your domain repeats, you got to get the same output the second time as well. So this one is a yes. Now, there's a special test that you can use to tell if a graph is a function or not, and it's the vertical line test. So how the vertical line test is you take any vertical line and you just kind of, and you can do this with your pencil or actually use your imagination. You just run it over the graph from left to right, and you're seeing if the graph crosses your vertical line more than once. In this case, at any location for x, it's not going to intersect the graph more than once, so this one would be a yes. Second one though, we're okay right here when we're at the vertex, but as soon as we go to the right, I see that the graph is intersecting my vertical line twice. So for any violation of it hitting twice, we have to say it's not a function. Now let's go ahead and look at this last one. So as I go ahead and I move it from left to right, so far only intersecting at 1. And then right here, this one on the left is touching and it's not touching on the right. When I'm exactly there in the middle, neither one is touching. And then when I move just a little bit more to the right, it's only touching one time. So this one would be a yes. So let's look at the difference between two types of functions, explicit and implicit. So explicit and implicit, what we're first looking at is it an explicit equation or is it an implicit equation? Then is it a function? So let's define explicit and implicit. So explicit means the equation has a variable that has been solved, or explicit means that it's an equation where a variable has been solved for, versus implicit, which means we have an equation that's not solved for a variable. So is one variable by itself? If that's a yes, it's implicit. If no variable is all by itself on one side of the equation, then it's an example of an implicit equation. So let's go ahead and see that in action. So for some of these, we're going to go ahead and we're going to figure out what it is in terms of y, and then is it a function? So we're going to change it from implicit to explicit. So let's go ahead and do number 1. To get y by itself, first I'm going to subtract x from both sides, leaving me -4y equals the opposite of x plus 20. Now I'm going to divide each term by -4, which would give me, and I will write this one out for you, negative over a negative makes positive 1/4 x. 20 divided by -4 is -5. So is it a function? Well, if I graph this, what would it look like? It would look like a line with a slope of 1/4. So this one is a yes, it's a function. So now let's go ahead and look at number 2. So on number 2, I have x squared plus y squared equals 25. I'm trying to get y by itself. So first I'm going to subtract x squared on both sides. Now, to get rid of the exponent of 2, I'm going to do the inverse of squaring, which is the square root. Whatever you do to one side, do to the other. Because we're taking a square root of an unknown, or it's plus or minus. So that would give me y equals plus or minus square root of the opposite of x squared plus 25. So, is this a function? Well, if we went on our calculators and we actually graph this, we would see it graphs as a half circle and a half circle, which means it's not a function. So this would be a no. Now you're probably wondering what I expect you to be able to do. So what I do expect you to be able to do at this point is solve for y on all of these. But what I don't expect you to be able to do is graph them. You'll be able to use a graphing calculator. So let's look at number 5. So I'm still trying to get the y by itself, and it's stuck inside a radical sign. So first I'm going to get rid of the x. So I have the opposite of y plus 1 equals the opposite of x plus 8. Now I'm going to get rid of the negative by multiplying every term by negative 1. So I get the square root of y plus 1 equals positive x, 1x I should say, minus 8. I change basically all the signs. So now I have to get rid of the square root sign, so I'm going to do the inverse of the square root, which is to square. So what I'm doing next is I'm squaring the left side, but I also have to square the right side. So when I do that, I get y plus 1, because the square cancels the square root, and then I'm going to keep this grouped, x minus 8 squared. Now I subtract 1, so I get x minus 8 quantity squared minus 1. Now my y is by itself. Now is it a function? Well, if we were to graph this, we would see that it's actually a parabola. We would see that it's actually a parabola with a vertex at 8, negative 1, and it would pass the vertical line test, so it would be yes, it's a function. Last but not least, we have function notation. So let's go ahead and take one of those functions that we did have, such as y equals 1/4 x plus 2. And all function notation is it says that for your output, instead of using y as the output, we use the notation f of x, or we could use a different letter instead of f, like g of x, h of x, whatever. But whatever you use, remember what follows is going to be the input. So sometimes you might see some functions that look like this, h of t. Well, what's my input? That number. So we read this f of x equals 1/4 x plus 2. And we interpret it as the value of the function f at x. So on number 7, if I wanted to evaluate f of negative 5, it means wherever I see an x, I'm going to replace it with the number negative 5. So if it says x squared, I put negative 5 and I square it, minus 6. I'm replacing the x with a negative 5, plus 23, and now I evaluate using order of operations. 25 plus 30 plus 23 makes 55 plus 23, which is 78. So let's look at one, like number 17, where we're evaluating not a constant, but an actual expression. So it says h of x is 2a plus 7 squared, because it said to square the x. Then where that second x is, I'm going to also put in 2a plus 7. This time it just says subtracted. And then I have a minus 1. Now, order of operations says I square, then I go ahead, distribute my minus sign, because it's like multiplying by negative 1 to that 2a plus 7, and then I combine like terms. So when I square 2a plus 7, remember it's 2a plus 7 times 2a plus 7. And so when I multiply that out, I get 4a squared plus what I should have written here was h of 2a plus 7, not h of x. So h of 2a plus 7 is 4a squared plus 26a plus 41. That's all, folks.